Good day, this is the Professor, CBMD PhD, and today is Wednesday, September 6, 1923. It is 10:56 and 25 seconds, p.m. Eastern Standard Time, and today's research, magnetic materials. So let's come to it here. Researchers use artificial intelligence to find new magnetic materials without critical elements. Date September 5th. 1923. Source: DOE, Ames, National Laboratory. A team of scientists developed a new machine learning model for discovering critical element-free permanent magnetic materials based on the predicted Curie temperature of new material combinations. High-performance magnets are essential for technologies such as wind energy, data storage, electric vehicles, and magnetic refrigeration. These magnets contain critical materials such as cobalt and rare earth elements like neodymium and dysprosium. These materials are in high demand but have limited availability. This situation is motivating researchers to find ways to design new magnetic materials with reduced critical materials. Machine learning is a form of artificial intelligence. It is driven by computer algorithms that use data and trial and error algorithms to continually improve its predictions. The team used experimental data on Curie temperatures and theoretical modeling to train the machine language algorithm. Curie temperature is a maximum temperature at which a material maintains its magnetism. As finding compounds with a high Curie temperature is an important first step in the discovery of materials that can sustain magnetic properties at elevated temperatures. This aspect is critical for the design of not only permanent magnets, but other functional magnetic materials. According to the scientific investigators, discovering new materials is a challenging activity because the search is traditionally based on experimentation, which is expensive and time-consuming. However, using a machine language method can save time and resources. The research team explained that a major part of this effort was to develop a machine language model using fundamental science. The team trained the machine language model using experimentally known magnetic materials. The information about these materials establishes a relationship between several electronic and atomic structure features and Curie temperature. These patterns give the computer a basis for finding potential candidate materials. And to test the model, the team used compounds based on cerium, zirconium, and higher. They wanted to focus on unknown magnetic materials based on Earth abundant elements. The next supermagnet must not only be superb in performance, but also rely on abundant domestic components. The scientific investigators and researchers say to synthesize and characterize the alloys, they found that the machine language model was successful in predicting the Curie temperature of material candidates. This success is an important first step in creating a high-throughput way of designing new permanent magnets for future technological applications. And this is the Professor of Space Technology, Advanced Physics, Mathematics, Computer Science, and Nature of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.